AB Calculus, Notecard 22, Trigonometry Derivatives. This is the 22nd video lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District. And this is the set of derivatives next to and after the sine, and also the cosine derivatives. So we're going to cover the rest of the 6 trigonometric ratios here in this lesson. The first one we see here is d dx of the derivative of tangent is secant squared x. And so, and also the derivative of secant is secant tangent. And then the derivative of cotangent is negative cosecant squared x. And the derivative of cosecant is negative cosecant cotangent. And there are little tricks to help us remember how to do things. One thing that one of our teachers in our district was Miss Tan, and as a memory device, we said that Miss Tan, you just write like this, she was very attractive, so attractive that she was not only sexy, she was sexy. Okay. Yeah, kind of corny. But what happens if you write these three together? Essentially, you can cross out whichever one, and whatever you have remaining is the derivative. So if we want to find what the derivative of tangent is, if we cross out tangent, what do we have left? Secant, which is secant squared. If we want to find out what secant is, we can cross the derivative of secant. We can cross out one secant. What do we have? Tangent secant. So that's a little helpful memory device. And likewise, for the cotangent and cosecant relationship, you can put negative COT, cosecant, CSC, and if we want to find the derivative of cotangent, if we just cross out the COT, what do we have left? Negative cosecant squared. If we want to find out the derivative of cosecant, we can cross out that cosecant. What do we have left? Negative cotangent cosecant. So just a memory device to help us remember what's going on here. Okay, let's go on and work out some problems related to this. I'll get my skinnier pen here. If y equals tangent x minus cotangent x, then find y prime. Well, y prime is going to be the derivative of tangent is secant squared x, so that's easy. And the derivative of cotangent is going to be negative cosecant squared, so and we'll parenthesize this x here like they had in the original. And we got plus because if you recall, we wrote the negative cotangent, cosecant. If we want to find the derivative of cotangent, we have negative cosecant squared, which and the negative here becomes positive, so this would be our y prime expression, or function for y prime equation. Next, to evaluate, the limit as h approaches 0, 4 secant x plus h minus 4 secant of x over h. And what we have here is the essential definition of derivative, which is this one. Limit as h approaches 0 of f of x plus h minus f of x over h. So according to this format, our f of x here corresponds to 4 secant x. So we can rewrite this as a function as f of x equals 4 secant x. And then, according to our little memory device here, tangent, secant, secant, since we want to find out f prime of x, that's going to be equal to 4, and we will have tangent x secant x. And so that's going to be it. And so the answer is going to be 4 tangent x secant x. Okay. And again, it comes down in this instance to recognizing the form of the definition of the derivative. 3. If a particle moving along the x-axis has a velocity given by v of t equals -6 cotangent t over 5t, find the acceleration. Well, our acceleration, a of t, is going to be equal to v prime of t. Okay, so let's go ahead and apply this here. So we're going to find the first derivative. I'm going to put now v prime of t equals a of t. And let's go figure out what that is. What I see here is a quotient of 2 functions. So I'm going to call this one up here high and the one down here low. And so we will say high is equal to -6 cotangent t, and our d high, derivative of our high, is going to be negative cosecant squared. So this negative becomes positive, so we're going to have 6 cosecant squared t. Okay, now our low is equal to 5t, and our d low is equal to 5. And so now we can write our derivative here. Low, which is 5t, d high, which is 6 times 6 cosecant squared t, minus high, and our high is -6 cotangent t, so minus negative, that will be positive 6 cotangent t, d low, which is 5, and all over low squared, so we'll have in the denominator 25 t squared. And then we can simplify things a little bit up here. Okay, a of t is equal to, we have 30 t, and then we have cosecant squared t, and then plus 5 times 6, 30, cotangent t, all over 25t squared. And if we wanted to, we could factor out that 30 and not that we have to do it, but so if we have 30 times quantity t cosecant squared t plus cotangent t all over 25 t squared, what we're going to have is a of t is equal to 20 over 25 reduces to 6/5, so we have 6 times quantity t cosecant squared t plus cotangent t, and then all over 5 t squared. Okay, so that's as simple as I know how to make it. Let's go to problem 4. Determine the point or points at which the horizontal tangents occur on the graph of y equals 2 cosecant x plus 3 on the closed interval from 0 to 2 pi. And so harkening back to this cotangent, cosecant aid, if we want to find the derivative of cosecant, we will cross out one of these cosecants and we have left negative cotangent cosecant. So the horizontal tangent line occurs where the derivative is equal to 0. So let's go ahead and do that. We have y prime is equal to, and we have negative cotangent cosecant, so we're going to say negative 2 cotangent x cosecant x, and then the derivative of 3 is 0. And so if we set the first derivative equal to 0, we will find where those horizontal tangent lines occur. So we have negative 2 cotangent x cosecant x. And according to the zero factor property, this equation will be a true equation when either of these ratios is equal to 0. And so we could say, we could write this out as 0 equals cotangent x, and also 0 is equal to cosecant x. Well, it so happens, as far as this cosecant equation, the cosecant is never going to be less than 1, or, well, yeah, it could be. It will not be between negative 1, or, yeah, between negative 1 and 1. So, we know that we can't get a 0 out of this one, but the cotangent we can, because if we put 0, and what is cotangent? It's going to be cosine x over sine x. And so basically, we can say 0 is equal to cosine x. And where is cosine x equal to 0? If cosine x is equal to 0 in only 2 places between 0 and 2 pi, and that would be right here at this point, 0, 1, and down here at this point at, by the way, this angle here is going to be pi over 2. And also down here, the coordinate pair 0, negative 1, and that angle is going to be 3 pi over 2. And so x is equal to pi over 2, x is equal to 3 pi over 2. And finally, it says what is determine the points. So we're going to have 2 points. I'm going to say points. We're going to find the totality of our coordinate pairs. So we have pi over 2 is our x-coordinate, comma, we don't know what's left here, and also 3 pi over 2, comma, we'll find that. So put down here y of pi over 2 is equal to 2 cosecant pi over 2 plus 3. And cosecant pi over 2, let's see, pi over 2, cosecant is a reciprocal of sine, so that's going to be 1. So that's going to be equal to 2 times 1 plus 3, which equals 5. So that will be 5, the point being pi over 2 comma 5, and y value at 3 pi over 2 is going to be equal to 2 cosecant 3 pi over 2 plus 3, and cosecant is the reciprocal of sine, and the sine is negative 1, and the reciprocal of negative 1 is negative 1, so we're going to get 2 times negative 1 plus 3, which is going to be equal to negative 2 plus 3, 1. So that's our other coordinate pair up here. Square 2 pi over 3 pi over 2 comma 1. So these are points at which those horizontal tangents will occur. Good luck, and thanks for viewing.